Hello everyone. In this video, I'll explain vertical motion, second part of rate of change, section 4. So, in this topic, we will be using the um, position function, velocity, and acceleration, the same as the horizontal motion. But the difference is in horizontal motion, the function is given in the questions. But in vertical motion, sometimes function is given, sometimes the position function is not given. We need to figure out what position function is. So what is the position function? It's negative 1 over 2 gravitational acceleration t squared plus vot plus so, where so is the initial position, bo is the initial velocity. So we know what g is. Gravitational acceleration is 9.8 meter per second squared. So when we simplify it with 2, we get negative 4.9 t squared plus vot plus so, where we have meter. The unit is given in terms of meter, but in some questions unit will be given in terms of feet. In this case we will convert meter to feet. 1 meter is approximately 3.2 feet, so when we do the conversion it's approximately 16. So instead of 4.9 we're going to write 16 when the unit is feet. So position function when the unit is feet is negative 16 t squared plus vot plus so. So if question doesn't give us the position function, these two are the functions that we are going to use depending on the unit in the question. And we need to know some information to understand the questions. If the question says the object reaches to its highest point, let's say we are throwing an object, it goes and reaches its highest point, then it means at that point that object stops, it turns down and it starts falling. So at that point, since the object stops, its velocity is equal to 0. So at highest point, the velocity is equal to 0. So that's what we're going to do to solve questions. We equalize the velocity to 0 when it's talking about highest point. And if that particle reaches the ground, hits the ground, then there will be no height. So the position will be 0. So in this case, we will equalize the position function to 0. We can also equalize SO to 0. It will make our job easier. All right. Okay, let's start solving questions. First question in the book. In a firework festival, a rocket is launched upward from the height of 4 feet. So from 4 feet, it's launched, and the initial velocity is 160 feet. Initial position is 4 feet. The first question is write the position function for the motion of the rocket. Now, position function is given. That's what we need to write. Look at the unit, it's feet. So we are going to use this formula. St equals negative 16 t squared plus VOT. VO is given as 160 plus SOT. SO is given as 4. No T, sorry. So this is our function, negative 16 t squared plus 160 t plus 4. Okay, we wrote the function. Now the question comes, what's the highest point the rocket can reach? So it starts throwing, you throw it, you launch it, whatever. And when it reaches its highest point, it stops and it starts falling down. So this is the motion, right? So at that point, when it reaches to the highest point, since the object stops, its velocity becomes 0. So we will equalize the velocity to 0. So how do I find the velocity? Velocity is derivative of position function, which is negative 32t plus 160. So we'll equalize this to 0 and find t. What is t? Bring 32t to the other side. 160 is 32t. Divide both sides by 32. We are going to find t as 5. 5 seconds. So we got RT, but this is not the question. Question is asking about highest point. So What is the position when t is 5? What is the position when it reaches the highest point? So we can write this as t as 5, our t is 5 now, as 5 equals the position function negative 16 times t, which is 5 squared, plus 160 times t, which is 5 plus 4. This is what we are going to calculate. So that will give us 404 feet. Okay. So when it reaches to the highest point, it goes 404 feet. All right, part C. What is the velocity of the rocket when it reaches 260 feet upward and 260 feet downward? So the object throws, you throw the object, it reaches 260 feet upward first and 260 feet downward. So what was the velocity at this point, and what is the velocity at that point? So to find velocity, we should know what the t is. To find c, we are going to equalize the position function to 260 first. So what is the position function? Negative 16 t squared plus 160 t plus 4 is supposed to be equal to 260. So this is the position. We equalize the position function to this given. Okay, now let's simplify this. Bring 260 to the other side. It is 256 equals 0. It looks very complicated. So I see 16, the common factor. Divide everything by 16. Negative 16 actually. It's gonna give you t squared minus 10t plus 16 equals 0. Now you can factorize this. When you factorize this, this is 2, 8, negative, negative, t. So it's going to be t plus 2, t minus 8. So our t's are negative 2 and 8. Sorry, 2 and 8. T minus 2, t minus 8. So our t is 2 and the other t is 8. So we got 2 t's. Now what we are going to do with this, we are going to find the velocity. So in the velocity, we are going to substitute 2 and we are going to substitute 8. What was the velocity formula? We get velocity by taking the derivative of position function, which we found in the previous question as negative 32t plus 160. V is negative 32t plus 160. So in this function, we are going to replace our t with 2 first. And replace it with 8. So what will the answer be? Answer, when I replace my t with 2, it becomes 96 feet per second. When I substitute t was 840, it becomes negative 96. So when I go upward, the velocity at this point is 96 feet per second. When I go downward, velocity at this point is negative feet per second. Since we are going down, velocity becomes negative. Here we are going up, velocity is positive. Like in horizontal motion, going right, velocity is positive, going left, negative. In vertical motion, going up, velocity positive, going down, velocity negative. When you stop, velocity is 0. Idea is sort of same. All right. Part D. What is the acceleration of each instant? So to find acceleration, we should take derivative of velocity. So acceleration function can be found by taking derivative of velocity. The velocity was negative 32t plus 160. Its derivative is negative 32. So we are looking for acceleration at each instant. So it is negative 32 feet per second squared. All right, so it's same for every at every point, every time. Part E. When will the rocket reach the ground? If it reaches the ground, the position function will be 0. So we will also set SO to 0. This is the easiest way of finding the answer. So position function was, what was the position function? Negative 16t squared plus 160t plus SO. The SO will be 0 when it hits the ground. So 0 equals 0. Now solve it. Negative 16 is common. T is also common. It's gonna be T minus 10. Let me correct this. Okay, negative 16t is common. Here I have t, here I have minus 10 equals 0. So t is 0 and t is 10. When t is 0, there is no motion. But 10, when t is 10, we hit the ground. This is impossible. So this is our answer. Right, we solved the first question. This was the first type. The equation is not given. We found the equation by ourselves. The second type, equation is given. When equation is given, it's easy. When equation is given, we may not be on Earth. When we are on Earth, the gravitational acceleration, because of the gravitational acceleration, our formulas are fixed, either this or this, depending on the unit. But when we are not on Earth, we will have a different position function. So in this question, in this ministry question, we are on the moon. A rock is thrown vertically upward from the surface of the moon. The function is given. How long does it take the rocket reach the highest point? When the rocket reaches the highest point, it stops, so velocity becomes 0. So find velocity. Velocity function is derivative of position function, which is 32 minus 1.60. This will be equal to 0. Bring 1.60 to the other side. Divide both sides by 1.6. So t will be 20, right? 20 seconds. So we got t. What we need is finding the highest point. So use this time in the position function as t as 20 equals 32 times 20 minus 0.8 times 20 squared. So this is the answer for the first part. Part A was asking about the time, how long does it take to reach its highest point. The second part is asking about how high does the rock go. The second part, we are inserting 20 for t in the position function to find how high the rocket goes. So the answer when we calculate this will be 320 meter. All right, this is such an easy question. Okay, we are done with vertical motion. There is no other type of questions. These are all we may have in exam.